So it's going through the second question on the third set of past paper questions for the Year 12 mechanics. As we read the question, constant force implies constant acceleration, and at some point in this question I would imagine some suvat is a good guess. 4 vector quantities, 1 non-vector quantity. We're told that when t is 0, the velocity is that. So that's going to be our initial velocity. When t is 3, we have that, which could be a final velocity after 3 seconds, couldn't it? But part A is find in degrees the angle between direction of motion when t is 3 and the vector j. So this is the velocity tells us the direction it's travelling in. So onto this diagram, I'm just trying to find Sharpies that have ink in them still. So the velocity is 1 minus 2. The velocity is 1 minus 2. That's the direction it's travelling in. And we want the angle between that and the vector j. J is in the y direction, so we want that angle there. Okay? Now, there is a right angle here. So if I work out this angle, I can work out theta. So tan alpha is 1 over 2. Alpha is tan minus 1 over half. So theta is and then in degrees the angle, we've got to look at it's 1 sig fig, 1 sig fig. Is that appropriate? I'm going to write it like that, but my feeling is it should really be 150, but I'm going to leave it as no mention of accuracy, so I'm going to leave it like that. Right, part B, find the acceleration. So acceleration, constant force, constant acceleration, suvat. So u is minus 5.7. V is 1 minus 2. IJ notation, column vectors, exactly the same. This just saves you some writing. T is 3. Not a vector quantity, vector, vector, vector. Because V equals U plus AT, A is V minus U over T, which is 1 minus 2, take minus 5.7 divided by 3. 1 take minus 5, 6. Minus 2 take 7 is minus 9. A third of that is 2 minus 3 meters per second squared. I'm just going to check that. It said the acceleration, not the magnitude, so I'm going to leave it like that. Okay, probably a bit cheeky to leave it in the column vector notation if it's all written in IJ for the rest of it. So if you're at all worried, write it back. Right then, part C, the magnitude of the force. Suvat, constant acceleration, forces. There's only one rule we have that links force and acceleration. Newton 2. Vector, vector, scalar. So the force is, in the question it says 2 kilograms. the force is going to be 2 multiplied by 2 minus 3, so 4 minus 6. So the force is 4 minus 6 newtons, or 4I takes 6J newtons. But the question asked for the magnitude of the force, so we apply Pythagoras to this. The size of the force is the square root of 4 squared and 6 squared, which is the square root of 16 and 36, 2 root 13, 7.2 newtons. Find in terms of t the velocity of, right, I'm just running out. I'll fit it in, I'm sure I can fit it in here. Right, d. The velocity, v is u plus a t. Super. So we could write that as u minus 5, 7 plus a multiplied by t, tick, tick. I could write it in ij notation instead. I could write it as minus 5 and 2t, they're the two I components, 2 bits of the I component. 7 take 3t j, but I'd be annoyed in both cases if we didn't put units on it. Either answer good. When is it travelling parallel to I plus j? So where I'm going to put this answer up here. So I'm just going to put the previous answer next to it. So the velocity is minus 5 and 2t, 7 take 3t. Oh, sorry, I realised what I've just written here. Newtons, meters per second there, wasn't it? Meters per second. Right, concentrate. When is it travelling to parallel to I plus j? So when is this velocity parallel to I plus j? When is that parallel to that? This is parallel to that when this is a multiple of that. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 are all parallel to that one. This is parallel to that when these two components are equal. Five t, 12, t is 2 2/5 seconds. Okay? If you have any more questions about that, ask, and so hopefully, if I tilt this back a bit, then you might be able to screenshot it right at the end. No, not quite. Yeah, if you want an answer, you can screenshot that.